Welcome to another Scikon ML2 tutorial. In this video, we'll explore multivariable regression using the KNeighborsRegressor algorithm. This technique is especially useful for predicting continuous outcome when multiple influencing variables are involved. We will apply it to a manufacturing dataset to see how it works in practice. Multivariable regression is a statistical modeling technique that examines how two or more independent variables impact a continuous dependent variable. Unlike simple linear regression, which only considers one predictor, multivariable regression accounts for simultaneous influence of multiple inputs. This method is particularly valuable in real-world applications where outcomes are shaped by interrelated factors, such as material properties or biomedical signals. Let's take a look at the dataset. It includes 6 key features. We have temperature, which affects material properties, and pressure, which influence process outcomes. There's also an interaction term, temperature times pressure, to capture joint effects. 2 engineered metrics are included. Material fusion metric, calculated as a temperature squared plus pressure cubed, and material transformation metric, defined as temperature cubed minus pressure squared. Finally, the quality rating is our target value, measuring the overall performance of the final product. The dataset contains 3,957 rows and 6 columns, with 5 input features and 1 target variable. This makes it a suitable candidate for multivariable regression model. We'll be using KNeighborsRegressor to predict the quality rating based on these input features. The KNeighborsRegressor is a non-parametric, instance-based algorithm. It doesn't build a global model from the data. Instead, it makes predictions by averaging the target values from the k-nearest neighbors to a new input. It relies on a distance metric like Euclidean distance to find those neighbors. Since it doesn't assume a specific data distribution, it's effective for model local nonlinear relationship. The choice of k affects the model's behavior. Smaller values allows for more localized responses, while larger values provide more general trends. We train the model using 80% of the data and reserve 20% for testing. After generating predictions, we evaluate performance using the R-squared score, which tells us how well the predicted values align with the actual target values. A higher R-squared indicates stronger fit. In this example, KNeighborsRegressor gives us a powerful way to predict outcomes by leveraging local patterns in the data without needing a traditional fitted model. Now, we've covered the background and theories in the slides. We'll switch over to the Scikon app to demonstrate how to apply the KNeighborsRegressor model using the manufacturing dataset. In this live demo, we'll walk through uploading the dataset, selecting features and the target variable, configuring model parameters, and evaluating predictions directly in the app. First, let's give our project a name, and in the description section, we can have a detailed description of this project. In the data section, let's choose tabular data type since our data is in CSV format. And we click Upload CSV and click this button to upload our data. After successfully uploading the data, we'll have these 2 tabs information available. The first tab is the overview of our dataset, and it shows all of the available features. And in the data tab, we have an overview and summary of our data. The first one is the null instances, the second one is the data types of the columns, and the third one is the unique values of the columns. Now, let's move to the pre-processing section. We choose our quality rating column as our target label, and then we choose our machine learning algorithm as the method. In the algorithm section, we choose our model. And in the metrics section, we choose R-squared for evaluation. After finishing all the above steps, we can click Perform. After a few seconds, we have our R-squared score ready. The R-squared score is close to 1, and it's round up to 1, which means our prediction is very accurate. This plot is good for one-dimensional input and one-dimensional output. Since we are doing multivariable regression, this plot does not work for our task, but it's great for one-input linear regression plotting. In the table section, we can see our y-test column values and y-predict column values. Y-test column is the ground truth of our dataset, and y-predict values are from our model's prediction. As we can see, these are very accurate predictions. And this has been our demo for KNeighborsRegressor. Thanks for watching.